All right, we're ready for 8.3, showing that a quadrilateral is a parallelogram. Now, I hope when you listen to these notes, you stop and say, wait, didn't we already take these notes? Didn't we already do this? But this is one of those cases where I'm going to present the information backwards from the way I presented it in 8.2. So 8.2 was properties of a parallelogram. Now I'm going to say, oh, look, you have a four-sided figure. Does it have properties that will make it a parallelogram? So it is going to sound a lot alike, but it's really not quite the same from the same perspective, maybe I should say. So my first theorem says if you have both pairs of opposite sides of a quadrilateral congruent, then you're going to have a parallelogram. So if the sides are marked, both opposite pairs are congruent. So AB over there is congruent to CD on the right, and BC on the top is congruent to AD on the bottom. Then that alone will make it a parallelogram. Okay? Followed right up again by if both pairs of opposite angles of the quadrilateral are congruent, then the quadrilateral is a parallelogram. So if angle A down here on the bottom left is congruent to angle C up here on the top right, and angle B on the top left is congruent to angle D on the top right, opposite angles are congruent, then you know you have a parallelogram. And you only need one of those to make sure you have a parallelogram. All right, so let's look here at this basketball hoop. I know many of you in your driveways have one of these adjustable height hoops. It says in the diagram at the right, AB is 36 inches and DC is 36 inches. Those are both exactly the same length, okay? And those are supports on our basketball hoop. Then it says explain why AD over here, this segment here, is always parallel to BC over here. Well, one thing we know is every time we change the height, those 36 inches don't change, right? Those bars move as far as at the angle, but the lengths themselves do not change. So we know the side lengths do not change on the bars, and where the bars are attached to the back of the hoop from A to D is 18 inches, from B to C on the pole is 18 inches, so those are also congruent lengths, and those can't change when you move your height of your basketball hoop up or down. So because both pairs of opposite sides are congruent, we know that that has to be a parallelogram. I'm just going to put by definition of, or by opposite sides congruent. That's what I want to write. By opposite sides congruent. Please do not use a theorem number. So if my opposite sides are congruent and I know I have a parallelogram, then by definition, AD has to be parallel to BC because a parallelogram has opposite sides parallel. All right, second page already. We have new theorems here at the top. If one pair of opposite sides of a quadrilateral are congruent, okay, we see those congruent marks right there, and we see parallel marks. So if one pair of sides are both congruent and parallel, notice we know nothing about the other pair of sides, but if that one pair is both congruent and parallel, then we know we have to have a parallelogram. And then another theorem, if the diagonals of a quadrilateral bisect each other, so if we know pieces of these diagonals are equal to the other piece on the same side, then we know that quadrilateral has to be a parallelogram as well. So if BD and AC bisect each other, we have a parallelogram. All of these except, this one is a little bit different than we heard before, but all of the rest, these are the same properties we heard of parallelograms. So now we're saying if we see these properties, it's got to be a parallelogram. So looking at example 2 here, move my paper. It says that the headlights of a car have the shape shown at the right. So when I look at this shape over here, I notice these opposite sides are congruent. I notice they have arrows, so they are parallel. So if BC is parallel to AD and BC is congruent to AD, then by one pair of sides, parallel and congruent, then we know that it's a parallelogram, okay? And then by definition of a parallelogram, you know opposite angles are congruent, so angle B will be congruent to angle D. All right, moving on to number 1 down here on our checkpoint. In quadrilateral GHJK, I'm going to draw a GHJK. Now, I don't know right now what kind of quadrilateral it is. It just said 4 sides. That's all it tells me. It says measure of angle G is 55. The measure of H is 125. And it says angle J over here is 55. It says find angle K. All right, so don't assume anything here, because the only thing we know for sure right now is it's 4-sided, and we know all 4-sided figures have how many degrees inside? 360. So we're going to check x plus 55 plus 125 plus 55 should equal 360. All right, so this is my handy-dandy calculator. 55 plus 125 plus 55, that's 235. And we have 360, we subtract that 235, and we get 125. Okay. So that's the measure of angle K. Okay, that's 125. So now that I know angle K is 125, do we have a parallelogram? And I don't want to know what theorem number. I'm just going to say yes, because I know opposite angles are congruent. All right, for number 2 here, what theorem can you use to show that the quadrilateral is a parallelogram? Well, again, we're not going to write down a theorem number. We're going to just say the rule. So I'm going to look and say, well, those two are equal, and these two are equal. So I would say the reason is diagonals bisect each other. Okay. Now, you have a worksheet for homework tonight, and I'm going to ask you, I wrote on the directions. I wrote it on there. It says, give the reason. Don't give the theorem number. Just like we wrote here, just say like diagonals bisect each other. Opposite angles are congruent. That's the kind of reason I want you to give on your homework tonight. All right, we are on page 3 here. It says, what value of x is this quadrilateral going to be a parallelogram? Well, I can already see that TS and QT are congruent. So that's one pair of, or one diagonal that's bisected. So I know that if PT and TR are also congruent, then my diagonals will bisect each other. And if my diagonals bisect each other, then I have a parallelogram. So I want my PT and TR to equal each other. So I want 5x to equal 2x plus 9. I'm going to subtract 2x, and I get 3x equals 9, divide by 3, and x equals 3. And then I can plug it back in there to see when x equals 3, what will those values be? Well, 5 times 3 is 15. 2 times 3 is 6. 6 plus 9 is 15. Yep, my diagonals bisect each other. So when x equals 3, my diagonals bisect each other, and that will be a parallelogram. Okay. A concept summary. But this is where I want to get maybe a little more, explain a little bit more so you understand what your job is here. Ways to prove a quadrilateral is a parallelogram, okay? Show both pairs of opposite sides are parallel. Okay, but how do you do that, okay? And more specifically, this is what I want to kind of go on a graph, because that's where we see it a lot and where I'm going to give it to you on homework and on maybe a test. If it's graphed, how do you show both pairs of opposite sides are parallel? How do you show anything's parallel? You find the slope. So if you're going to do this work, we need to find 4 slopes, okay? And remember, if it's graphed, you can count those, count up and over, right? That's what we do there, find 4 slopes, and we need opposite sides, the opposite slopes to be equal. That's what I'm looking for if I'm going to be able to say opposite sides are parallel. All right? Number 2, show both pairs of opposite sides are congruent. So if I know the opposite sides are exactly the same length, I know I have a parallelogram. How do I do that on a graph? How do I show sides are congruent? Well, we find the lengths of those sides. How do I find lengths? 4 distance formulas. So we're going to find 4 distance formulas, okay? And once again, we want opposite sides to be the same. Opposite sides need to have that same length. For number 3 here, show both pairs of opposite angles are congruent. I'm going to be honest, they need to give us information or we can't. This is not a way we can prove it. Okay, not that we have in our toolbox of things we can do. So on number 3, we're not going to be able to do it. Okay, so back to number 4 then, show one pair of opposite sides are congruent and parallel. Okay, so we're only talking one pair of sides now. The other side we don't even talk about, we don't do anything with. But the opposite sides are congruent. We're going to need to find 2 slopes. And then we're also going to need to find 2 distance formulas. And of course, on the same pair, right? On the same pair. And they need to be equal. So on the same set of numbers, we want to find the slopes and the distance formula. All right, last one here. For number 5, show the diagonals bisect each other. Okay. Well, this one's probably the trickiest and takes the most steps. First, you're going to need the midpoint formula to find the midpoint. Okay. Then you need 4 distance formulas. On each side of the diagonal. Okay, so 4 distance formulas and sides of the same diagonal need to be equal. Okay, that's what we're looking for on that one. Sides of the same one need to be equal. So here's the deal though. If you're given a graph and you have to show how it's a parallelogram, you really, for the most part, get to choose which one of these 5 you do. Obviously, number 3 is not a choice. So you have 4 to choose from. You can either find 4 slopes, you can find 4 distance formulas, you can find 2 slopes and 2 distance formulas, or you can do the midpoint formula and then 4 more distance formulas. So you decide which one are you the most comfortable with. You do that, but make sure you show me the math that goes with it. All right, so let's look at our last page and let's practice kind of what we just went over. So over here I have a shape here and I want to show that it's a parallelogram. Okay, in my margin I had some formulas. They're not showing up as well as I wanted, so let me go write them. Okay, if you want side lengths, we need to use the distance formula, right? x2 minus x1 squared plus y2 minus y1 squared. Okay, so that's if I'm going to find lengths. If I'm doing this parallel lines, I'm using slopes. So you can use the formula and do the formula y2 minus y1 over x2 minus x1. Or, don't forget, you can count them, right? If you count up, it's positive. If you count down, it's negative. If you count to the right, it's positive. If you count to the left, it's negative. Remember, it's rise over run, so you go up and down first, left or right second when you count those. Okay, it says show that this quadrilateral is a parallelogram. Okay. I'm going to admit this is probably not the way most of you are going to do it, but I'm going to do the math here so you see a little bit of everything. So one way to show that a pair of sides are congruent and parallel, okay? So we're going to do one pair congruent and one pair parallel. It's the same pair though. So congruent is going to find us the side lengths, okay, the distance formula, and parallel will do the slope. So I'm going to do a mixture of both so you see this work. Okay, we're going to focus on sides KL and MN. Just those 2 sides. That's the only 2 sides we're going to work on. So first we're going to do the distance formula. Well, K looks like it's at 2, 2, and L is at 4, 4. Okay, so we're going to find the distance between them. So subtract those x's, 2 minus 4. Subtract those y's, 2 minus 4. 2 minus 4 is negative 2. 2 minus 4 is negative 2. Negative 2 squared is 4. Negative 2 squared is 4. 4 plus 4 is 8. I know that simplifies down, but I'm going to be able to tell you, I'm not worried about what it simplifies to. I'm worried if it matches MN. So that's what I'm more worried about. Okay, so let me do MNs. M is at 4, negative 2. And N is at 6, 0. Does that seem right? Yeah. Okay, so I'm going to subtract those x's. 4 minus 6. Subtract those y's, negative 2 minus 0. Well, 4 minus 6, that gives me negative 2. Negative 2 minus 0 is negative 2. Negative 2 squared is 4. Negative 2 squared is 4. 4 plus 4 is 8. Okay. Because both of them equal the square root of 8, they are congruent, right? So now I know one pair of sides are congruent. Okay. Now, can I figure out if they are parallel? Okay. So you can count it or you can do the formula. I'm going to do the formula first and then go back and count it so you can see it. So for KL, I'm going back to these points. It's always y2 minus y1. So 2 minus 4 on my y's, 2 minus 4 on my x's. I get negative 2 over negative 2, which equals positive 1. Slope for MN, subtract those y's first. Negative 2 minus 0 on top. 4 minus 6 on the bottom for my x's. Negative 2 minus 0 is negative 2. 4 minus 6 is negative 2, which simplifies to 1. Are they parallel? Yes. Right? They have the same slope. Okay. If you're not a formula person, but you like the graph, go over and count it. Count up 2 to the right 2. Up 2, right 2. That's positive 2 over positive 2, which equals 1. Okay, for MN, I start here at the bottom one. I count up 2. I count right 2. Okay. I get positive 2 over positive 2, which equals 1. So you can count it, or you can do the formula. Either way, I get the same slope. So is this a parallelogram? Yes. So it's a parallelogram by one pair of sides, congruent, and parallel. Okay? Make sure whatever math you do, you tell the reason that that math supports. Okay, so make sure you give me that reason. All right, for number 3 here. For what value of x is this quadrilateral a parallelogram? Well, if it's a parallelogram, then my diagonals need to bisect each other. I already know this FH is bisected, so that means I want the other one to also be bisected. So I want 4x minus 7 to equal 2x. Subtract 4x, I get negative 2x, divide by negative 2, and x equals positive 3.5. So if x equals 3.5, I have a parallelogram. If x equals any other number, I don't have a parallelogram. All right, number 4 says, explain another method that could be used to show the quadrilateral KLMN in example 4 is a parallelogram. Well, I already proved one pair of sides congruent and that same pair of sides parallel. What if I went back up? I'm going to count another slope because it's quick and easy, okay? So, totally different color here. I'm going to count from M to K this time. I count up 1, 2, 3, 4, to the left 2. So I counted up 4, left 2. That simplifies to negative 2. Let me try it over here on M to L here. I count up 1, 2, 3, 4. That's a positive 4 when I count up, but I went left 2. So negative 2. That's a slope of negative 2. Okay. If I have a slope of 1 on this one and a slope of 1 on this one, they're parallel. And if I have a slope of negative 2 on this one and a slope of negative 2 of this one, they're parallel. So when I come back down and answer this question on number 4, what's another way I could use? I could find 4 slopes. And I did, right? I just found 4 slopes. And I could just say opposite sides are parallel. And those 4 slopes prove those opposite sides parallel. Okay? I could have also gone back up and found 2 more distance formulas and said opposite sides are congruent. So multiple ways we can do this. All right, so you have a worksheet for your homework tonight, a worksheet to practice on. You need to make sure you give me the rules. I don't want theorem numbers. I simply want you to say things like opposite sides are congruent. Opposite angles are congruent. Diagonals bisect each other. I want you to use those properties we've talked about that go with parallelograms. If you have questions, please let me know.